Let's discuss the coefficient of determination. The symbol for it is capital R squared. The way you get it is to take your correlation value and square it, or take little r and square it. Since you're squaring r, which falls between -1 and 1, when you square the extremes, you'll get a positive 1. This is where we get the upper end for our coefficient of determination. If you take the weakest value correlation can be and square it, this will give back an r squared of 0. This is the lower boundary on r squared. To interpret r squared, you can see it as the percent of variability in y explained by the linear regression on x. For example, if r squared is 25%, then we could say 25% of the variability in y can be explained by x. Let's get even more specific. Let's say that y stands for a student's GPA and x stands for a student's SAT score, and we want to predict GPA based on SAT score. You could almost visualize it as looking like this. Here's GPA, and 25% of this GPA can be predicted using the SAT score. Let's write this in words. 25% of the variability in GPA can be explained by SAT score. The reason why the coefficient of determination is used more than correlation is that it's easier to interpret. Oftentimes, the coefficient of determination is used in prediction studies where one variable is used to predict a second variable. Let's go back to our example. A total of 210 patients, 143 with HCV, remember that's hepatitis C. So 143 patients with hepatitis C infection were evaluated for cirrhotic status of the liver, both by needle biopsy and US. According to the pathological findings, a fibrosis score 4 on the histology activity index was the gold standard for the diagnosis of cirrhosis. A U.S. scoring system consisting of liver surface was used to describe the severity of hepatic damage. Cirrhosis was found in 51 or 36% of the 143 hepatitis C patients pathologically. The U.S. scores were significantly correlated with the hepatic fibrosis scores. In HCV-related cirrhosis, a U.S. score had a correlation of 82.4%. Let's review what the correlation between hepatitis C and cirrhosis was. We came in and said it was the 82.4%, so we know correlation is 0.824. Let's use this to find our coefficient of determination. Capital R squared is the symbol for it, and the way you get it is to take your correlation value and square it. This gives 0.678 or 67.8%. The second part of the question asks us to interpret this value. Let's discuss a visual first. Remember, we're trying to predict cirrhosis using hepatitis C. And we saw that about 67.8% of this can be explained by the hepatitis C. So 67.8% of the variability in cirrhosis can be explained by the regression on hepatitis C. Let's say we want to go in reverse. Let's say we know the coefficient of determination and we wish to find the correlation value. Here's how you'll do it. Take the square root of your coefficient of determination. You'll keep the positive root if you have a scatter plot that's increasing, or in your linear regression, the value of m is positive. You'll keep the negative root if you have a scatter plot that's decreasing, or in your regression if the value of m is negative. Let's go through a couple of examples. I couldn't get the symbol y hat to copy into here, but remember that this should read y hat like this. Y hat equals 55.5 plus 23.8x, and the coefficient of determination is 0.84. What is the correlation? We know that we'll take the square root of r squared. Now the question is, should we keep the positive root or the negative root? Since the slope, 23.8, is positive, we'll keep this as a positive root. And we now know that the correlation value is 0.917. Here's our second example. We have a scatter plot and a coefficient of determination of 0.96. We'll take the square root of this number, and looking at the scatter plot, there's an overall negative direction, so we'll make the root negative. That tells us that the correlation is negative 0.9798. Here are the works cited used in this lecture.